4.2, the unit circle. This is a big one. This one we're talking about all about the unit circle. So first, what is a unit circle? Well, it's exactly kind of what it sounds like. It's a circle with a radius of 1. So in each direction, if you just go 1, you make a circle with a radius of 1. Right? Unit circle. So in one case, it's just what it sounds like. But what we use it for is to find so many values in trigonometry. So this is like the unit circle in all this glory. It's this right here. So you could find out every sine, cosine, tan, cosecant, secant at all these special angles for us, 30, 45, 60, 90 in both cases. Now, you're going to have to evaluate trig functions using the unit circle. Now, there's different ways to do it. Some people memorize it, not me. And some people do the triangle way, and some people do other ways. I'm a triangle person. But the general gist of this is this. We want you to be able to evaluate something like, what is sine of 60 degrees? Now remember, all sine is a ratio. So no matter what triangle you are, this is saying what's the ratio of the sides if the angle is 60 degrees? Well, what's the ratio of opposite right hypotenuse particularly? Because no matter how big or small the triangle is, it always has the exact same ratio. And we're going to use the unit circle to figure that out. But how does this work? Well, let's say I make a basic triangle. Right? Now, if we put it on the xy plane, here's my angle. Up and down is y, the y value. Left and right is the x value. Hypotenuse, it is a unit circle, so the hypotenuse is going to be 1. Because we're going to do it on the unit circle. Well, if that's my triangle, let's list out the sides. This is opposite. This is adjacent. This is hypotenuse. So we could figure out the trig functions here. What is sine of theta? SOHCAHTOA, right? Opposite over hypotenuse. Y over 1, or just y. Let's just put y. Make it easier to see, right? Because it's y over 1, so just y. Cosine of theta. So SOHCAHTOA, adjacent over hypotenuse. That's just going to be x. And tan of theta is just going to be sine over cosine, opposite over adjacent, sorry, y over x. Also known as sine over cosine. So how does that relate to the unit circle? Besides the fact that you use the unit circle to do this. If I want sine of 60, all we're going to do is go to the 60 degree angle. We have this point here, right? Which one is sine? Sine is the y value because of that. Because in any triangle on this unit circle, sine's always the up and down value, which is the y value. So sine of 60 is going to be rad 3 over 2. Right? So sine's always going to be the y value. I like to say sine e. And cosine's always the x value. And then tan is y over x, like we have over here. So that's how the unit circle works. Now, how's that helpful besides the fact that if you have it, you can just read it? Well, I'm not going to give you the unit circle. You can memorize it. I wouldn't. That's a lot of stuff to memorize. But if you could do it, go ahead. There's lots of little tricks to do it. What I do is I build it every single time and call it the triangle way. So that involves memorizing the 3 special triangles we've learned about before, right? 45, 45, which is 1, 1, rad 2. A 30, 60, 90, which I make into 2 triangles. A 30 degree triangle, 1, 30 small, it's the 1. Rad 3, hypotenuse 2. And a 60 degree triangle. 60 is big, so it gets the radical 3, 1, and 2. So the triangle way is you have to memorize these triangles. And then we're just going to use SOHCAHTOA and draw our angle, and we're going to build the unit circle every time we need it. So that's the triangle way. That's what I'm going to show you here. If you want, you can also memorize. You can also find different ways online. Memorizing isn't as bad as it sounds. There's like different tricks to it. There's a pattern. You notice there's only like 3 answers, and you just repeat and repeat and repeat. But I prefer to build a triangle every single time. So this is a triangle way. So first thing we're going to do is we're going to graph the angle in standard position. Well, let's put a little example problem up here. Let's do sine of 60, the one we just did. Right, so step 1 is graph the angle in standard position. So here's my thing. Here's 0. Here's 180. Here's 90. 60 will be in the first quadrant. And then we're going to make a right triangle with a reference angle. So all that means is you can go down to the x-axis. No matter where you are, you only ever go to the x. That's only where everything goes. So make a little triangle, and then you should make a little right triangle. This angle right here is your reference angle. In this case, it's a 60 degree angle, right? We went up 60. That's 60. So this is a 60 degree angle. If that's a 60 degree angle, you should know the sides, because right, we're just going to fill this side out. We're going to fill all the sides out with our 30, 60, 90 triangle, the stuff we memorize. So in a 60 degree triangle, opposite the angle is radical 3, Hypotenuse is always 2, and this is 1. So there's my triangle. All I gotta do now is use SOHCAHTOA. We're doing sine. Sine is so opposite over hypotenuse. Rad 3 over 2. And that's it. That's me building a triangle every single time, right? So get the exact same answer, right? Sine of 60 was rad 3 over 2. That's where you got it from. So that's the way I do it. I build it every time, and eventually get good enough. You just build it in your head. But that's the general consensus. We'll do a few more examples. So cosine 240, we'll hit some important concepts on the way. So here's 0, here's 90, here's 180, here's 270. Now 240 is between these two, so let's put it somewhere between. It doesn't really matter, it's just a sketch. Now the key thing here is this. You always go to the x-axis, right? This is my x, this is my y. Don't ever go to the y, it's always to the x. So I'm going to go straight up, make a right angle. This was 240. How much is the reference angle? Well, this is 180, this is 240, they are 60 apart. So this is 60. And again, we should know a 60-degree triangle. So that is rad 3, because 60 is big. Hypotenuse is always 2, and this is 1. Now there's the thing here we gotta talk about. This is an XY grid. So anytime you go to the left, you should be negative. And anytime you go down, you should be negative. Right? Hypotenuse is always positive. No matter where it's at, hypotenuse is positive because you find it by doing a quadratic formula. So this is always going to be positive, but when you go left, it's negative, when you go down, it's negative. So now if I want cosine, so SOHCAHTOA adjacent over hypotenuse. So negative 1 over 2. Now just to double check, let's see if that matches our unit circle. Remember, cosine is the x value. So we go to 240, and you find the x value, negative 1/2. Okay, sine of 3 pi over 4. We haven't done a radian yet. Let's have how you do a radian. Well, same thing. The hardest part is, do you know how to draw? The hardest part is a couple of things, actually. We should talk about this. In radians, the reference angle is given by the denominator on the bottom. So if it's pi over 4, that's going to be a 45-degree reference angle. Pi over 3 is going to be a 60-degree reference angle. And pi over 6 is going to be a 30-degree reference angle. I know these feel like they're flipped. They are not. When you divide by 3, you get a bigger slice. When you divide by 6, you're getting a smaller slice. So that's why when you divide by 6, you're dividing into smaller things. It's 30. When you divide by 3, you're dividing into bigger things. It's 60. So that's the way that works. 45 is like right in the middle, Goldilocks zone. So sine of pi over 4, I already know. I know it's 45 degrees. That's a good thing about radians. I know what angle it is. You just got to try to figure out what quadrant it is, because that's to determine if it's positive or negative. That's the key here. So we just got to figure out what quadrant it is. Remember my trick? Make this 4 over 4. And this would be 2 pi over 8 pi over 4. Where does 3 pi over 4 land? Well, remember we start here. It is positive. So we're going to go up. And we haven't reached 4 over 4 yet. We're a little short, so we're right there. 3 pi over 4. You always make a triangle with a right angle. It's the x-axis. Remember, it is going to be 45 degrees because it's over 4. Or 4 is always 45 degrees. So we should know the sides. It should be 1, 1, radical 2. But one of these has to be, well, not one of these has to be, but one of these is negative. Right? We went to the left. So this one should be negative. We went up. That's positive. Hypotenuse is always positive. We want sine. So opposite over hypotenuse. So you got 1 over rad 2. If you want, you could rationalize it. If you do, you get radical 2 over 2. I accept both answers. Doesn't matter to me. Okay, let's do a few more. Tan of 5 pi over 3. Another radian one. So we're going to go 0. We're going to go pi. 2 pi. Right? So keep the common denominator, 3 over 3. This equals 6 pi over 3. Right? Because you go 3 this way and you go 3 back this way. It is a positive 5 pi time. We're going up. So we're going 3 over 3. Not there yet. We have 2 and 4 by negative 5. So go around again. 6. So a little shorter than that. We're in this quadrant. This is 5 pi over 3. Make a right triangle. And it's over 3, so it's automatically 60. And when you divide by 3, you get a big slice. And again, we should know the size from 60. 60 is always big, so it's radical 3. Hypotenuse is always 2, and this is 1. Any of these negative, radical 3 is negative because it's going down, it's negative. And we want tan, TOA, opposite over adjacent. So negative radical 3 over 1, or just negative radical 3. So like that. Right here we got cosecant 5 pi over 6. So same idea. Here's 0. Here's pi. We're going to do 6 over 6 and 2 pi or 12 pi over 6. All right, we start here. It is positive. We're going to go here. This is 6 over 6. We have not hit that yet. We're a little bit short, so we're going to be in here. That's 5 pi over 6. We always go down to the x-axis. Over 6 is automatically 30. So I should know my sides. This is 1, radical 3, and 2. And again, we went to the left, so this should be negative. Now, the one thing here, we're doing cosecant. So you gotta remember, it's easy to do the opposite. The opposite is cosine. So ka. So adjacent over hypotenuse. So negative rad 3 over 2. But our answer is actually the cosecant, so we're going to flip it. 2 over negative rad 3. Again, you can leave it at that, or you can rationalize it. If you want to see it rationalized, you just multiply by the radical. You get 2 rad 3, well, negative 2 rad 3 over square root of 9, which is 3. So either way, it's fine for me. Okay. A quadrantal angle. Quadrantal angles are when you fall on the axes, right? All the ones we did right here, we fell in between the axes, so we made triangles. What happens if you fall on the actual line? Well, if you do that, it's called a quadrantal angle. So that's when you fall on the line. And we do those a little differently. You're not going to make a triangle for those. What you're going to do is you're going to use a unicircle to its full potential. So let's see sine of pi. So here we go. 0, pi. I'll put 2 pi over 2, 3 pi over 2. 2 pi. It is pi, so we're going to stop right there. That's our graph, is pi right there. Like it went from here to here. So, like that angle. So how do we do this? Don't forget, it's a unit circle. So this point here is 1, 0, like a normal XY grid. The point here is 0, 1. The point here, negative 1, 0. The point here, 0, negative 1. So if you fall on a quadrantal angle, you have to use the unit circle points. And then remember, what is sine of pi? Sine e, sine is the y value, so it's the y value there. So whatever the y value, so anytime you have sine and you land on a point, it's always the y value. If you have cosine, it's always the x value. If you have tan, it's y over x. So that's how you do a quadrantal angle. So here are the trig functions again. Like we talked about, right, when it's on a unit circle, sine is the y value, cosine is the x value, tan is y over x, and then these are the reciprocal functions. If they want you to find the 6 trig functions, we kind of already did that. So let's skip past. We haven't done a negative yet. Let's do the negative one. So if we're going to do that one, right? So here's xy grid. Here's 0. Here's pi over 2. Here's pi. And 2 pi. It is negative, so we're going to go down. Now remember, anytime there's a 1, there's no number on top, it's in the first quadrant. So normally we're right here, but we are negative, so we're going to be down here. So my angle is going to be like right here. Negative pi over 3. We're going to make a right triangle with the x-axis, as always. Over 3 is automatically 60. And then from there, we should know our sides. That is radical 3. That is 1. Hypotenuse is always 2. If you notice, hypotenuse is always 2 on our triangles. Sometimes it's a radical 2 when it's 45, but it's always a 2. So 2 there, 2 there, 2 there. When it's 45, it's a radical 2. Like that, and then one of these has, they don't have to be. In this case, one of these is negative. If you're in quadrant 1, it's all positive. But this one's negative, so we went down. Just kind of say, try and do the negative really. So now if I wanted 6 trig functions, I could just do it really quickly. Sine, cosine, tan, theta of theta, of theta. I guess of t in this case. Sine would be opposite over hypotenuse. Cosine would be adjacent over hypotenuse. And tangent would be opposite over adjacent. So negative rad 3. Then if you want the other 3 trig functions, remember, all you have to do is remember which one goes with which. Sine goes with cosecant. So you just gotta flip it. 2 over negative rad 3. Cosine goes with secant. So 2 over 1 equals. And then tan goes with cotan, the easiest one. So let's flip it 1 over negative rad 3. And that's how you do the 3 trig functions at a value there. Domain of sine and cosine. This is an important concept. So the main domain of sine and cosine is all real numbers. You can plug anything in. The range, however, the numbers you get out are only between -1 and 1. It's all in this unit circle. So the range is the important part. The range of sine and cosine is always between 1 and -1. So you can never get a value of sine and cosine that's higher than 1 or less than -1. So that's an important concept. Periodic functions are just functions that repeat themselves. That's what a periodic function is. It repeats. And that's going to happen when we do trig functions because of the Clopensets angles, how you keep on going around in a circle. How we talked about how 400 degrees is the same thing as 40 degrees. So sine of 400 would be the same thing as sine of 40. Because of the fact that it's this Clopensets that keep on going around in circles. So that's what periodic means. Your answers don't repeat themselves after a certain amount. And with that, since that happens, it depends on how the function is, but you can do little shortcuts like the cosine and secant are called even functions. So that means like remember when we did an even function that they're the exact same thing over the x-axis. So plus and minus doesn't really mean anything to them. So like if you have cosine of -30 degrees, it's going to be the same, -30 degrees. It's going to be the same thing as cosine of 30. Because they're going to be the exact same distance away and you get the exact same y value. So that's what happens with even functions like cosine and secant. And those are easy to remember in the sense that secant is a reciprocal of cosine. That's why cosine is, if cosine is even, so is secant. And then sine and tangent are odd functions. So you can like pull the negative out. Again, these are just like shortcuts. If you know them, make your life a little easier. You don't have to actually use them as much. Use the period to evaluate the sine and cosine of this. So sine of 13 pi over 6, we could do without the period. If I do sine of 13 pi over 6, I'll go 0, pi, 2 pi, right? So remember my trick would be you make this 6 over 6, and you make this 12 over 6. So if I was drawing it, I should be like, okay, where's 13 pi over 6? Well, here's 6, here's 12, 13 would be a little bit higher. So it'd be right here. 13 pi over 6. It's over 6, so it's automatically 30, which means it has to be 1, radical 3, and 2. So you should know your sides. And then sine is so it's opposite of hypotenuse, 1/2. That's one way to do it. But sometimes if that's like 93 over pi over 6, you probably don't want to go around 93 times. So what you can also do is just find the Clopensets angle. 3 pi over 6, let's just subtract 2 pi, right? Find the Clopensets angle. Make it over 1. Common denominator, 6 over 6. So this is 12 pi over 6. And you get pi over 6. So you could have solved this by doing sine of 12 pi over 6. And you got the exact same answer. Let's try that with this one here. Right, instead of figuring out what this is, let's just do a Clopensets angle. This is negative, so we're going to add 2 pi. Common denominator over 1, 2 over 2. So I get 4 pi, and I get -3 pi over 2. Well, that's still negative, but we can write it a little better. Let's do it again. You can just add another Clopensets angle. Let's add another 2 pi. Common denominator, we know this already. It's over 1 times by 2 times by 2, so I get 4 pi. So I get pi over 2. So this is the same thing as just saying cosine of pi over 2. Right, so you could do that. And then we just got to figure out what cosine pi over 2 is. Real quick, here's 0, here's pi. Pi over 2 is halfway. So remember, when you land on the line, you do not draw a triangle. You do not draw a triangle if you land on the line. You're supposed to know that point. It's an xy point. It's a unit circle, so this is a point of 1. And in a coordinate point, it's 0, 1. It's right, we're going up. Now you gotta remember sine and cosine. Sine, sine's the y, cosine must be the x. So cosine's the x value here, which is 0. So cosine of -10 pi over 2 is the same thing as cosine of pi over 2, which is just 0. Because it landed on the unit circle, and the x value was 0. Okay, you can also put in your calculator. I've got the calculator real quick. So if I want to do sine of 2 pi, so in this case, notice you have to make sure you're if they plug in a radian, you have to make sure you're in radians. So if you do like, right now I'm in degrees. So if I did sine of 2 pi over 3, I get that, but that's not the right answer because it's in the wrong mode. I have to make sure I'm in radians. select radians, quit, and plug the same thing back in, sine of 2 pi, and I get 0.860. That's the right answer, not this guy. I think I rounded wrong. Let's put this 866. Okay. And cotan, how do you do, I don't see cotan here. How do you do cotan? You gotta remember, cotan is the same thing as 1 over tan. Right? Calculator's not gonna have cotan most likely, so you have to put 1 over tan. You have to know your math. 1.5. Again, still in radians. So 0.071, we'll say. So that's how you put in your calculator. And that is it.